This is the first part of the recording of the Module 5 lecture. In this module, we're going to learn about discrete random variables and their probability distributions. All right, at the end of this module, the expectation is that you should be able to explain what a random variable is, distinguish between discrete and continuous random variables, explain what a probability distribution is and the conditions it must satisfy. Also, you will learn to calculate the mean and the variance of a random variable. Also, list the characteristics of a binomial experiment, calculate probabilities for a binomial random variable, and its mean and standard deviation. Also, learn that you should be able to list the characteristics of a hypergeometric experiment and calculate probabilities for the random variable that has a hypergeometric distribution, hypergeometric probability distribution. And finally, you should be able to list the conditions to calculate probabilities for a Poisson random variable and its mean and standard deviation. Okay, this is what we intend to learn in this module. All right, let's start with the fundamental idea of what a random variable is. And this you can find it in section 5.1 of your text. All right, going back to the beginning of chapter 4, when we learn about probability, you might recall the definition of an experiment. So experiment is a process that when performed results in one and only one possible outcome. However, these outcomes cannot be predicted before you actually perform the experiment. Also, we talk about the sample space, which is a collection of all the possible outcomes of the experiment. We mentioned the sample point, which is just a single element in the sample space. And the random variable, which is a new definition that we haven't seen, is a function that assigns numerical values to the outcomes of an experiment. So now we're taking what is the ideas of probability, and we are adding this idea of the random variable that takes the outcomes of an experiment and it assigns numbers to it. All right, let's look at an example, very simple example that is very straightforward, I think. In this case, we have an experiment where we roll a six-sided die, and the possible outcomes of rolling that die is the number of dots on the side of the die facing upwards. So the possible outcomes when you roll the die, or the dots that you will see on the face of the die facing upwards, it could be a 1, a 2, 3, 4, 5, 6 dots. In this case, a random variable very simply assigns, if you see a single dot, it assigns a 1. If you see, or if you roll a 2, or in other words, you see 2 dots on the top face of the die, then the random variable will assign it a 2. And so on for the other possible outcomes of rolling a die. So the random variable assigns numbers. And this is a more succinct way of speaking about the random variable. Like saying I roll a 1, I roll a 2, or whatever number, instead of saying, well, the face of the die that landed upwards has 2 dots. Well, it's much easier to talk about numbers. All right, and you will see how we will construct the probability distributions. All right, so this is an example, a very simple example of what the random variable is and how it assigns numbers to the outcomes of an experiment. Later on, we'll see a little more complicated situations. All right, the next concept that is very important that you make a very clear distinction in your mind is the type of random variable. You may recall in chapter 1, we talk about the types of variables. If you can picture that tree diagram, you see that we have categorical variables, or we call it qualitative variables. And then on the right-hand side, you have the quantitative variables or numerical variables. And those numerical variables break into continuous variables or discrete variables. Well, now we're going to call those discrete random variables and continuous random variables. So now we're talking about numerical variables, and it can be classified as discrete random variables or continuous random variables. So a discrete random variable will assume a countable number of finite or infinite of distinct values. Countable means that you can count those numbers, and in this particular case, looking at the number of dots on a die, see the random variable takes the countable values 1, 2, 3, 4, 5, and 6, and this is a finite set of distinct values. So this is discrete because there is no values between 1 and 2 or between 2 and 3 and so forth. Now, a continuous random variable consists of every possible value in an interval on the number line. For example, here we have the random variable is the lifetime of a battery in hours. So in essence, the lifetime of a battery could be any value between, in this case, 0 and 500 hours. So there is a continuum of values between 0 and 500, and the random variable can assume any value in that interval. All right, so in this module 5, we're going to talk about probability distributions of discrete random variables. So we're going to talk about this in chapter 5. In chapter 6, we're going to talk about the probability distributions of a single continuous random variable, the normal distribution. All right, so now let's talk about, now we saw what a random variable is, and now we saw the types of random variables, discrete or continuous random variables. Now let's talk about the probability distribution of a discrete random variable. All right, I put this diagram that I mentioned before. We saw this in chapter 1, except now that I'm talking about discrete random variables and continuous random variables. So depending on the type of random variable that you have, that is the probability distribution that you can use. So if you have a discrete random variable, then you could use perhaps the binomial probability distribution, or the hypergeometric probability distribution, or the Poisson, and there are many more. If the random variable is continuous, then you can use the normal probability distribution, or the exponential probability distribution, or the log normal. Again, there are many probability distributions, and we're going to talk just about a few of them. All right. So what is a probability distribution? This is closely associated with the frequency distribution that we saw in chapter 2. So in this case, the probability distribution of a discrete random variable, we're going to use the letter X, capital X, to designate a random variable. Lists all possible mutually exclusive outcomes, and the outcomes of the experiment, the values that the random variable can assume, we're going to call them lowercase x, or little x, of a discrete random variable and the corresponding probability. So in other words, when you have the probability distribution, you're going to see two columns. In the left column, all the possible values that the random variable can assume, and on the right hand side, the corresponding probability that the random variable will assume a particular value, and the probability associated with that. All right, and we'll see an example to clarify this. So now a probability distribution also, for you to call it a probability distribution, it must satisfy two conditions. That is, all the probabilities must be between and 0. That is, the probability that the random variable assumes any particular value must be between 0 and 1. And this is expected. That's what we saw at the beginning of chapter 4. Also, if you sum the probabilities of every possible mutual exclusive outcome, it must be 1. That is, the sum of the probabilities that the random variable assumes each of the values, if you sum all those probabilities, they must add to 1. If any of these two rules are violated, what you think is a probability distribution, it is not, because it does not satisfy these conditions. And these are very important conditions, because everything that we do assume that the probabilities are between 0 and 1, and the sum of all the individual probabilities must be 1. All right, here's a very simple example, that one experiment where we roll a 6-sided die. We saw that the random variable assigns numbers 1 through 6 to all possible outcomes of rolling the die. So here is the probability distribution of this random variable. So the possible values that x can assume is 1, 2, 3, 4, 5, or 6. Those are the only possible values that this random variable can assume. Now, the probability of rolling a 1, well, there is only one possibility of 6 possibilities. So the probability of rolling a 1 is 1/6, or 0.1667. The same for rolling a 2, or rolling the die and ended up with 2 dots facing up. That means the random variable will take on the value of 2. Again, that's 1 out of 6 possibilities. And as you can see, for every case, the probability is 1/6, or 0.1667. All right, so now if you notice, each probability for each of these possible values of the random variable is between 0 and 1. Now, if you sum these probabilities, you will see that it's exactly equal to 1. So this is the probability distribution of the experiment of rolling a die. So with this, before you roll the die, you say, well, what is the probability that we'll get a 2? Well, I know it's a 6. So I can give you the probability. Now, when you roll the die, the probability of any of the possible outcomes is 1/6. But before you roll it, we really don't know which number will come up. All right, so this is an example of a probability distribution. Here are 3 examples, and the question is, do you think that any of this is a probability distribution? Well, if we look at case A, you have the possible values of the random variable, and then you have the probability that the random variable assumes each of these values. So here are the probabilities, and you see all the probabilities are between 0 and 1. Well, that's good. Now we need to sum these probabilities, and they must sum to 1 if this is a probability distribution. If you sum these values, you see that we end up with about 0.84 or 0.85. I don't remember the quantity, but you can add them. These numbers do not add to 1. Here's the second case. So this first case, case A, is not a probability distribution. Does not satisfy the second rule. Now let's look at the probability distribution in case B. In this case here, the possible values of the random variable and the corresponding probabilities that the random variable will assume each of these values. And then if you sum these numbers, you will see that, well, first of all of these probabilities are between 0 and 1. So that's good. We satisfy rule 1. If you sum these numbers, then you see that you get a 1. So yes, this is a probability distribution because we satisfy the 2 conditions. Now, in case C, we have the possible outcomes of X, and then you look at the probabilities of each of these outcomes, and then you get this negative probability. Well, you know that the probabilities cannot be negative, so immediately you discount this as being one case of a probability distribution. Why? Because a negative probability is not possible if you have a true probability distribution. All right, so remember, a probability distribution must satisfy the 2 conditions, that every individual probability is between 0 and 1, and the sum of the probabilities that the random variable is equal to any of the values of the random variable must be 1. The sum of all those probabilities must be 1. All right, let me see. Let's stop here. In the next segment, I'll talk about the mean and the variance of a discrete random variable.